Now, I would like you guys to look at the following exercise. Take some time to revise and look through the notes before this, and try to fill in all the answers by yourself. Then we can go through it and I'll explain to you each of the solutions. Feel free to pause the video and resume when you have done the exercise. Now let's begin. So there are four symbols here that we have to use. The first symbol refers to being an element of a set. The second one, with the line crossing the belong to symbol, indicates not an element of the set. The third one refers to being a proper subset of a set. And the last one means not a proper subset of a set. For every question, first you can look at the left side and see whether the left side of the equation, is it a set or is it an element? If it's an element, then you can only show it with either the element of symbol or the not an element symbol. If the symbol on the left side is a set, then you can show it with either the symbol representing proper subset or the symbol representing not a proper subset. In the first example, we know that on the left side is a set containing 1, 2, and 3, and the right side is a set containing 2, 3, 4, 5. As you can see, number 1 is on the left side but not on the right side. So we can say that this is not a proper subset of 2, 3, 4, and 5. 7 and 8 are both elements on the left side and they exist on the right side. So we can say the set containing elements 7 and 8 is a proper subset of the set containing 5, 6, 7, 8, 9. The third one, on the left side of the equation, you can see it is not a set. It is simply an element. That means we can only show it with the symbol element of or the symbol not an element of. As you can see, 10 is on the left side but not on the right side. So we can say that the element 10 is not an element of the set containing 2, 4, 6, and 8. Next one is similar. We have purple, an element on the left side, but the set containing yellow, pink, and blue on the right side. Similarly, we will say the element purple is not an element of the set containing yellow, pink, and blue. The next one you can see on the left side is a set containing only one element. It might be confusing a bit because there's only one element, but note that this element is actually inside a curly braces. That means that on the left side is a set. So now we're comparing set on the left side, which contains only 0, and the set on the right side. You can see that 0 is an element of the set on the left, but not of the set on the right. So we say the set containing 0 is not a proper subset of the set containing 1, 2, and 3. This one, if you look carefully, the left containing curly braces with nothing inside is the empty set. On the right is also the empty set but represented by a different symbol. So they are essentially the same thing, and we know that an empty set is not a proper subset of itself. This is because to be a proper subset, the set on the left must be strictly smaller than the set on the right. In this case, the set on the left, which is the empty set, is the same as the set on the right. Next, we have the element 9 on the left. And we know that on the right is referring to a set where x is an odd number. Obviously, 9 is an odd number, so we can say 9 is an element of the set where x is an odd number. Now, on the left are a set containing 1, 2, and 3, and on the right, we have a set defined by x is a factor of 6. First, what are the factors of 6? If you actually write it down, you know that it will be 1, 2, 3, and 6. So we can say that the set on the left containing 1, 2, and 3 is a proper subset of the set on the right because it is smaller than the set on the right, and every element on the left is also an element of the set on the right. On the left, we have the element 12. On the right, we have a set where x is a multiple of 4. That means x can be 4, 8, 12, 16. The element on the left is clearly an element of the set on the right. The next question, where we know x is a prime number, let's start listing now the first few prime number. Namely, x can be 2, 3, 5, 7, 11. Now, on the left is a set containing 2, 3, and 5. Since the set on the left is smaller than the set on the right, and every element on the left is also in the set on the right side, we can say that the set containing 2, 3, and 5 is a proper subset of the set X, where X is a prime number. Now recall the definition of a prime number. 1 is actually not a prime number. So in this case, we know that the element on the left containing 1, 3, and 5 is not a proper subset of the set X, where X is a prime number. Wow, last one, let's finish it quick. The set on the left represents X, where X is an even number, and the set on the right represents X, where X is a positive integer. So think about it this way. On the left, you have like integers from 2, 4, 6, 8, 10 all the way, while on the right you have x equal to 1, 2, 3, 4, 5 and all the way. You can see that every element in the set on the left is also in the set on the right side. Therefore, we will say that the set containing x where x is an even number is a proper subset of the set where x is a positive integer. Now let's continue with the library analogy that we have used earlier on to further reinforce the concept of subset, proper subset, complement, not a subset, empty set, and the number of elements. Imagine the library is the largest collection of all books ever published. Now let's consider a specific section in the library, say the science fiction section. Let L represent the set of all books in the library, and SF represent the set of science fiction books. We know that every book in the science fiction section is also a book in the entire library. So we can say that SF is a subset of L, because every element in SF, meaning every book in SF, is also in set L. The science fiction section is a proper subset of the set L because it contains some, but not all the books from the library. There are other books in the library that are not in the science fiction section. For example, there are history books or romance books. So we can say that set SF is a proper subset of set L. The complement of the science fiction section in the library are the books that are not science fiction. These include books from, let's say, the history, romance, mystery, detective, comics, and other sections. We can denote the complement of SF by this symbol that looks like an apostrophe. Imagine if you have a list of books, say, A Brief History of Time and 1984. Imagine if A Brief History of Time is not in the library at all, perhaps it is a private collection book, then this set containing these two books is actually not a subset of the library collection. Imagine you're looking for a specific kind of book that the library doesn't have, For example, like Martian farming techniques. If the library doesn't have such a book, then the set of Martian farming books in the library is an empty set. The number of books in any section can be considered as the number of elements or the cardinality of that section. For example, if the science fiction section has 200 books, the cardinality of set SF is 200. We can write it as the number of elements of the set SF equal to 200.